Today we're going to be taking a look at measuring line segments. Now remember, a line segment is a collection of points between a definitive beginning and definitive end called the endpoints. Now every point along a line segment can be denoted by a coordinate that marks its specific location. So for example, if I take a look at my line segment up here, AE, I see that the coordinate of A is at -4. And if I want to find the distance or the space between B and D, what I'm looking for is the distance between points B and D on that segment. Now, distance is always going to be positive. Even if you're walking backwards, you're walking a positive distance. So distance can never be negative. If I want to know the space between point B and D, I'm simply counting the amount of linear space between these 2 points. So if I count that up, that's 1, 2, 3, 4.5. So I'd say the distance between point B and D is 4.5. Let's take a look at the example of finding the distance between point A and D on our line segment. A has the coordinate here at -4. D has the coordinate here of 2.5. Now we can always find the distance by subtracting the 2 coordinates and then taking the absolute value. Remember, absolute value always returns the positive amount. So if I want to find the distance between A and D on my line segment, I'm going to take the absolute value of the difference of their coordinates. So that's -4 minus 2.5. Now keep in mind, it doesn't matter which direction we subtract them in. This is going to be equal to the absolute value of 2.5 minus the coordinate at A, which was -4. Either way I do this, I'm going to end up with the absolute value of -6.5, and that's going to be equal to the absolute value of 6.5. Because either way, these are both equal to that distance or the amount of positive space between A and D, which is 6.5. Let's take a look at another example. We want to use this same segment above to find the length of BE. In other words, find the distance or the amount of space between point B, which is at -2, and point E, which is at 5. So I'll set it up as the absolute value of -2 minus 5. Now that's going to return the absolute value of -7, which we know is +7. So the amount of space, positive space between B and E should be 7. If we count it out, there's 1, 2, 3, 4, 5, 6, and 7. All right, in the segment addition postulate, one of the many truths that we get throughout this book, it says that 2 smaller segments add up to equal the whole segment. So take, for example, segment AB and segment BC. If I know segment AB has a certain length and I add it to segment BC, the 2 segments should add together to give me the total segment AC. So that's all this postulate says. AB plus BC have to add up to equal the whole segment AC. Let's apply that segment addition postulate here in example 1. It says we want to find the value of x and then use that value to find the length of DF. The picture we are given is that we have segment DF, which is 2x, and segment FE, which is x plus 1, adding up to equal the whole segment DE, which is 22 inches. So let's write an equation. 2x plus segment FE, which is represented by x plus 1, must add up to equal the whole segment, which is 22. Now, from here, it's just algebra. We're going to combine like terms. 2x plus 1x is 3x, plus 1 is equal to 22. We're going to get x by itself by subtracting 1 over from both sides of the equal sign. Now we have 3x equals 21. Now we're going to get rid of the 3 that's attached to the x by multiplication by dividing both sides by 3. And now we get x is equal to 21 over 3, which is 7. So I found my value of x. I can now substitute this back into my expression for DF to come up with DF is equal to 14 inches. Okay, in our next example, we have a story problem. It says on a subway route, station C is located at the midpoint. I'm going to underline midpoint and remember that the midpoint divides a segment into 2 equal or congruent segments. Now, C exists between stations A and D. So I'm going to start out by drawing myself a picture right now. Here's my route from A to D, and I know that C is the halfway point. In other words, CD is congruent to AC. These little tick marks indicate that they have the same length. Now I'm going to read further, and it's going to tell me that station B is located at the midpoint between A and C. So I'm going to come right here between A and C, and I'm going to place station B. It also divides segment AC up into two equal smaller segments. All right, now we're also given that AD, the distance from the beginning to the end, is 2.4 kilometers. We want to find the distance between B and D. So our job is to figure out that distance from B to D. All right, now if 2.4 kilometers represents the entire train route, then I know the halfway point, which is C, must represent half of 2.4. So if I take 1/2 of 2.4, then that's going to give me 1.2 kilometers. Now I know that that's the distance from A to C and then from C to D. So each one of these smaller segments inside is 1.2 kilometers. Likewise, I know that B is the halfway point between A and C. So I'm going to take half of 1.2. When I take half of 1.2, I get 0.6 kilometers. Therefore, from A to B is 0.6, and from B to C is 0.6. Now, recall, I wanted to find the distance from B to D. Well, B to D is the addition of segment BC and CD. Therefore, I'm going to take 0.6 and add it to 1.2. So 0.6 plus 1.2 gives me 1.8 kilometers. So the distance from station B to D should be 1.8 kilometers. All right, our next example, we read that T is the midpoint. And again, that's bolded, and I'm going to circle it because that tells me something about these two segments. It tells me that RT must be congruent to TS. So I'm going to put tick marks on that, indicating that those two segments have equal length. Now it says if RT is 3x and TS is 5x minus 10, we want to find the value of x and RT. It says, hint, what does midpoint suggest about these two? It suggests that they're equal. Now, if two things are equal, we can set them equal to each other. So I'm going to set the expression 3x equal to 5x minus 10. From here, I'm going to use algebra to combine like terms. I'm going to subtract 3x over to the other side here. So I have 0 equals 2x minus 10. And now I'm going to add 10 over to the other side of the equal sign. So I have 10 is equal to 2x. Now I got to get x by itself, so I'll divide both sides by 2. And x is equal to 5. So we found our value for x. We now have to go back and find the value of RT. So if I substitute that in for my expression for RT, I find that RT is equal to 15. And therefore RS should be twice 15, making it 30. All right, in our final example for today, we see that C is between A and B. Now notice it just says between, it doesn't say midpoint. So we don't know that AC is equal to CB. But it says AC is denoted by the expression 2x plus 8. So I'm going to label that. And I know that CB is equal to 18. We know that the whole segment AB is represented by this expression 4x. We want to use our segment addition postulate, which says the two smaller segments, AC and CB, have to add up to equal the big segment for x, or AB in this case. Go ahead and write an equation and combine like terms and solve for the value of x.